Now we'll start working our way through the components of a typical hydraulic system. And it begins with the pump pumping fluid out of the tank. And the pump sends fluid, usually oil, throughout the system, and that resistance raises the pressure. And as you will see in this artistic drawing, a hydraulic system is a closed loop. So the pump pumps the oil, it goes and does some work, then it returns through a return path and back to the tank. And the pump is driven by a motor. It's an electric motor, usually a three-phase motor. That's what we use in industrial systems. And it might be a 1200 RPM or an 1800 RPM. Those are standard sizes. Oftentimes you buy this outfit as one unit. I guess FYI, hydraulic pumps are always positive displacement, which means it's the same volume of oil no matter what pressure the system is. And I just say that because if you encounter something like a pump in a water pump on a well, that's not positive displacement, so just by contrast. Basic idea is you do something to open a cavity in the pump, which creates a vacuum, and the difference in pressure draws fluid up into the pump, and then on the next cycle you push the fluid back out, and then you go back and do it again. And pumps are rated by a couple of things. One is how much oil goes through the pump in one cycle, so that's called its displacement. And then the other size is how many gallons per minute or other flow rate, how much goes through per time, per minute, let's say. So displacement and flow rate. Another just point of clarification, pumps by themselves do not create pressure in the system. What they do is they create flow. If you had a pump pumping away and you had an open hose at the end, well, there would be no pressure other than atmospheric. So it's when the fluid encounters a load, that's when the flowing fluid creates pressure. So there are three basic kinds of pumps that you can find in a hydraulic system. The expensive one, the one that you can use in really high pressure systems, tends to be a piston pump, and those come in different flavors. You can get pumps where the pistons are arranged in a circle, a radial pump. You can get a thing called a swash plate, where this plate is tipped, and as it rotates it pushes on pistons. And you can get a bent axis pump, which is kind of similar operation. On the other end of the spectrum, so the lowest cost pump is a gear pump, and it's low cost, it's more noisy, and gear pumps come in several flavors. One kind is an external gear pump, so these are basically spur gears, and the oil goes around the outside of the spur gear and gets pushed up through an opening. Or you could have an internal gear. This is kind of like a planetary gear inside a ring gear, and as this thing turns, as you can see, because it's off center, the size of the cavity changes as the thing turns around. Probably the most common type of internal gear pump is the Gerotor Pump, which I think is short for generator rotor or something like that. Probably the most common type of pump in hydraulic systems is a Vane Pump. So this is in the middle of the spectrum, middle cost, middle noise, middle capacity, middle efficiency. And as it goes around, the centrifugal force, I know that's not a real thing, you physics people. Centrifugal force pulls those vanes outward until they seal against the body, And this too is off-center, like in a gear pump. And so these cavities fill with oil, and as the thing turns around, it's under pressure and the oil gets squeezed out the outlet. So these are fairly smooth running. A couple of things to watch out for in hydraulic systems. One is entrained air, and when air is entrained, what that means is some bubbles of air have gotten trapped inside the oil. And if you were to look at the oil in a clear container, you'd actually be able to see the bubbles. So that won't actually kill your system, but it doesn't work very well. So oil is a non-compressible fluid, and when you've got air bubbles in there, suddenly it is compressible, so it's, as you see at the bottom, it's spongy. It's not a precise operation. And then you can get foam on the top caused by those air bubbles, which would appear in your tank. If you have too many bubbles, you can wind up with a situation that is severe, and that's called cavitation. Cavitation, and you'll know when your system is cavitating because it's loud. It sounds like the thing is beating itself apart, which it kind of is. Cavitation is where the oil actually changes from a liquid to a gas. It actually boils at room temperature, and that's caused by there being a vacuum in there, or at least a very low pressure, which might be caused by some kind of restriction or too small a thing. And as these bubbles form and explode, they create these intense shock waves, and those shock waves hit the surface of your pump. And here's a picture of a pump that had cavitation, and you can see why cavitation is so noisy. It just chews the heck out of your system. So when you hear that, you know we need to do something. And the people who do the troubleshooting are going to be looking for things like, well, is the line blocked? Maybe the oil is too thick and it's not moving through the line. Maybe it's not moving through the line because the lines are too small or something happened to restrict the line. Or maybe you've got too much entrained air, or something's funky with your pump. Other people will be doing the troubleshooting, but it's just nice to be informed and know what's happening when you hear this loud hammering noise. Okay, but what we're here for is to make drawings, to learn about hydraulic drafting. So let's think about symbols. And a standard idea, whether we're in hydraulics or electricity or other stuff, is when you have a thing that rotates, you are probably going to represent that with a circle. Here is a symbol for a hydraulic pump. It's a circle because it rotates, and what makes this a pump symbol is there's an arrow pointing out. So think about what a pump does. It sucks oil out of the tank and it pumps it out into the hoses and tubes out into the system. So when you see a circle with an arrow pointing out, right off the bat you know, ha, that's a pump. A note at the bottom of this slide points out that pump symbol doesn't tell us anything about what kind of pump somebody has specified. Could be any kind of pump. This symbol just represents the function. This is the pump function. And you could have a pump set up, or you know, you purchased one that can go either direction, bi-directional. And that kind of pump has arrows pointing out on each end. So that's a bi-directional pump. Last slide. Look at the picture in the middle. When you see a symbol with a sloping arrow through the middle of it, that means variable. And you are going to see variable symbols on pumps, on hydraulic motors. Over in the world of electrical stuff, you'll see variable all kinds of things like potentiometers and rheostats and variable capacitors. So just know that Sloping arrow, ha, that means variable. On the left, we have our plain old garden variety, plain old pump with a constant flow rate, so it's not variable. And then over here on the right, here's a sloping arrow, so we know this is variable, but there's something else going on. There's a box stuck to the side, and that represents a pressure compensated pump. So you can set this pump at a different pressure setting, and then this pump will keep the pressure at that preset level no matter what. So there's our plain garden variety fixed displacement pump, arrow pointing out. Here in the middle is our variable displacement pump, and here on the right is our pressure compensated pump.